Okay, so now we're going to be talking about number 4 from the Unit 1 and 2 AP packet. Let's see what it says. Let f be a function defined as follows. So we can see f of x is a piecewise function, the top is an absolute value function, the bottom is a polynomial, and b are constants. For part A, it says, if a equals 2 and b equals 3, is f continuous for all x? Justify your answer. Well, at this level, we can see the absolute value of x minus 1 plus 2. That's going to be a continuous function. Ax squared plus bx, that's a polynomial, and those are always continuous. But the question is, because it's a piecewise function, where they overlap, which is x equals 1, will it be continuous there? So the first thing I'm going to do is I'm going to rewrite this function. And I'm going to say the top part is still absolute value of x minus 1 plus 2 for values less than 1. And for the bottom piece, I know what a and b are, so I'm going to write that in. 2x squared plus 3x for values of x that are greater than or equal to 1. Now, since it says, is f continuous for all x, justify your answer, the only way you ever want to show continuity is using limits. The goal is the left-hand branch going to be equaling this right-hand branch at the same y value? Now, although we can intuitively write this, we need to show this using limits. It's the only way you'll get credit on the AP test. So the idea here is saying the limit of f of x as x approaches 1 from the left. Okay, and we need to make sure we work on our limit notation. So the first thing is we say the limit. The next part is of what are we taking the limit? That's f of x. And then underneath it, we write where are we approaching? Well, we're going to figure out what that equals. That's going to equal the absolute value, because we're using the top half, x minus 1 plus 2 evaluated at x equals 1. Well, if I plug in 1, I can see 1 minus 1 is 0, plus 2 equals 2. Now that's just the left-hand branch. We need to see what the right-hand branch is going to give me. So again, the limit of f of x as x now approaches 1 from the right. So now we're using the polynomial, 2x squared plus 3x. So that's going to be 2x squared plus 3x evaluated at x equals 1. And if I plug that in, I see I get 5. Already, I know it's not continuous. I can see the left-hand y value is 2, the right-hand y value is 5. And to kind of get an idea of that, it would look something like this. The left-hand value is approaching 2, and the right-hand value is approaching 5. There's a gap, so it's not continuous. We have to complete our thought using sentences and showing why we are saying they are not equal to each other. So, we're going to write f is not continuous for all values of x because, well, what's our reasoning? The left-hand side is not equal to the right-hand side. So that because the limit of f of x as x approaches 1 from the left does not equal the limit of f of x as x approaches 1 from the right. Now, AP grading takes a little different spin on how we award points. In AP, we don't take away points, we actually award points. So the first point will come from showing that the left-hand limit is equal to 2. The next point will come from the right-hand limit, showing that it's equal to 5. And the third point for this problem will come from justifying your answer and answering the question. It does say, if a equals 2 and b equals 3, is f continuous? You answer the question by saying f is not continuous because, and make sure you show that the limit from the left is not equal to the limit from the right. Moving on to part B. For the next part, it says Describe all values of a and b for which f is a continuous function. So I'm going to rewrite f so we can see quickly. I reset it, so I said a equals a and b equals b because I can't use what I had from part A before. So describe all values of a and b for which f is a continuous function. Again, because we're talking about continuity, again, we have to use limits. Well, in order for f to be a continuous function, the limit of f of x as x approaches 1 from the left should equal the limit of f of x as x approaches 1 from the right. Well, from earlier on, we saw that the left-hand limit is equal to 2, but now the right-hand limit, we're going to actually have to evaluate at ax squared plus bx when x equals 1. And if I do that, I get a plus b, which is equal to 2. Now, some people get nervous at this stage because they're hoping to find actual numbers for a and b. Well, the directions do say describe all values of a and b. Describing is different than finding. Finding, you would actually have values as an answer. Here we're describing. Well, our description is simply saying this. A plus b is equal to 2. The sum of a and b, if that is equal to 2, that means this will be a continuous function. And as far as points go, this question is worth only 2 points. One is by denoting that the left-hand limit will equal the right-hand limit, and the other is for finding the description. The sum of a and b will equal 2. Now, for the last part, part C. For what values of a and b is f both continuous and differentiable? Well, the first part is saying f has to be continuous. Well, we can say for f to be continuous, a plus b should equal 2, and we have that from earlier on. Now, for f to be differentiable, we have to think about what that means. Well, in order for f to be differentiable, it's already continuous. It just means that the graph can't have a sharp corner. So in order for it to not have a sharp corner, the slope from the left has to equal the slope from the right. To kind of give you a picture of that, if one graph looks like this and another graph looks like this, the slope from the left is equal to some positive value, and the slope from the right is not equal to a positive value. So therefore, it's already going to be different. Even if the two graphs are both positive, this slope might be 1, and this slope might be 1/2, and that still causes a crease right in the middle of those two. And that's where the sharp corner comes from. To find the values of a and b so that f is differentiable, what we really need to say is the limit of f prime of x, because when we talk about slopes, we're referring to the derivative function. The limit of f prime of x as x approaches 1 from the left has to equal the limit of f prime of x as x approaches 1 from the right. So I look at my functions from what I have earlier on, and it says, from the left I use absolute value of x minus 1 plus 2. Well, if you remember, the graph of that is a v with the vertex at x equals 1. So if I take a look at the left side of the graph, and I'm trying to estimate the slope, well, the slope is simply the multiplier in front, the 1. So therefore, the left-hand limit of f prime of x as x approaches 1 will be negative 1. It's down 1 over 1 slope. Now for the right side, we don't have that luxury of just looking at the graph. We have to look at the function ax squared plus bx. Well, in order to find the derivative of that, I can use the power rule. That would be 2ax plus b, but this is going to be evaluated at x equals 1. So to complete this, we're going to say negative 1 is equal to, we plug in 1, so 2a plus b. Now, right now we have an equation with two variables. And earlier we actually had the same thing. That forces us to come up with a system. That system will be a plus b equals 2, and 2a plus b equals negative 1. From here, we can use substitution, elimination. I'm going to multiply the top one by negative 1. That'll give me negative a minus b equals 2, negative 2. Bottom one remains the same. And if I add, that gives me a equals negative 3. Plug that back in, you get a equals negative 3 and b equals 5. And there we have our answer. To get an idea of where the points come from, you get 1 point for showing you're going to be taking the limit of the left-hand derivative function and setting equal to the limit of the right-hand derivative function. Another point for coming up with the relationship between a and b such that the slopes are the same. You get 1 more point for showing that you're using a system from both equations, from part B and part C, to find a and b. And finally, 1 last point for having the values of a and b together. So this question was this part was worth 4 points. So in total, this entire question is worth 9.